The protective shield at the Chernobyl nuclear plant, built to contain the radioactive wreckage of the 1986 disaster, is back in the news after the UN nuclear watchdog found that a February drone strike had weakened its ability to do its main job, keeping radiation sealed in. During a safety inspection, the International Atomic Energy Agency, or IAEA, said that although the structure had not suffered permanent damage to its load-bearing framework or monitoring systems, the strike had compromised its core safety functions. The repairs were carried out immediately, but the agency warned that full restoration is essential to prevent the structure from degrading further. Hello and welcome to ThePrint. My name is Soumya Pillai and I'm here to explain what the Chernobyl safety shield is, how it was designed, and how it has managed to control radiation leaks for so many decades. All this in the backdrop of the IAEA's recent confirmation of its damage. To understand why this matters, it helps to look at how the shield came to be. The Chernobyl nuclear power plant is located in northern Ukraine, near the abandoned city of Pripyat, about 100 kilometers north of Kyiv, close to the border of Belarus. When the reactor number 4 of Chernobyl exploded in 1986, it didn't simply destroy a building. The blast tore open the nuclear core itself, scattering fuel, graphite, and highly radioactive dust into the atmosphere. The World Nuclear Association notes that the accident caused the largest uncontrolled release of radiation ever recorded from a civilian facility, with radioactive material escaping for nearly 10 days. Two radionuclides were especially dangerous: short-lived iodine-131, which posed an immediate health threat, and long-lived cesium-137, which contaminated land for decades. Soviet engineers knew that they only had days to contain whatever remained inside the smoldering crater. To contain lethal radiation, they built what came to be known as the sarcophagus, a massive concrete and steel enclosure assembled in the second half of 1986. The idea was simple in principle but effective in execution. Lock the radioactive core inside a thick shell to stop dust and debris from spreading. Walls up to 4 meters thick absorbed radiation, steel beams and plates sealed visible gaps, and quick and dirty ventilation filters tried to prevent pressure buildup. Because cranes and electronics failed in the extreme radiation, soldiers and emergency workers, known as liquidators, were sent in short bursts to drop concrete slabs or weld steel panels before running out again. The structure was meant to last only about 30 years. Moisture seeped in, condensation accumulated, metal rusted, and by 2000s, there were fears that parts of the sarcophagus would collapse, releasing radioactive dust trapped inside. This led to one of the most complex engineering projects in the world, the New Safe Confinement, or NSC. Completed in 2019 after years of planning and nearly 2 billion euros in funding from 45 countries and international organizations, the NSC is a giant steel arch designed to enclose both the ruined reactor and the failing sarcophagus. Because radiation at the site was still dangerous during the construction, the arch, which is about 108 meters tall and 257 meters wide, was built about half a kilometer away and then slid into position on special tracks. Inside, the structure is lined with stainless steel to prevent radioactive particles from escaping, and it is kept airtight with membranes and engineered seals. The interior is maintained under slightly negative pressure so that air can flow in but not out. Any air that does leave passes through powerful HEPA and charcoal filters to trap contaminants. The enclosure also stabilizes the environment inside, preventing condensation and moisture-related corrosion, one of the main reasons the original sarcophagus deteriorated. The NSC is built to survive tornado-strength winds, earthquakes, and heavy snow loads, conditions that the original 1986 structures could never have handled. But the shield is now facing threats that the designers did not anticipate. In February this year, a drone carrying a high explosive warhead struck the Chernobyl site during the Russia-Ukraine conflict. The blast triggered a fire and damaged the protective cladding on the NSC. Russia has denied responsibility, but the IAEA confirmed that the strike caused significant harm to the structure's confinement capability. This is not the first time that Chernobyl has been drawn into the ongoing war. In 2022, Russian forces seized the facility for several weeks, and movement of heavy vehicles disturbed the contaminated soil, causing a temporary spike in radiation levels before the site was returned to Ukrainian control. Now, to be clear, the recent damage does not mean that the shield is collapsing or releasing radiation, but it highlights a serious vulnerability. The NSC's job is to isolate what remains of Reactor 4, the melted nuclear fuel, graphite, dust, and debris, still intensely radioactive nearly 4 decades later. Anything that weakens the airtight enclosure risks allowing moisture, air, or particulate movement inside, which could accelerate corrosion or destabilize structures already weakened since 1986. The IAEA has stressed that comprehensive repairs are now essential to ensure long-term nuclear safety. That was all from me. My name is Soumya Pillai, and you were watching The Print.